Good day, my name is William Balaguera. Today we will talk about the Stanford Conference Document Analysis of Algorithms. One question: what does it mean to be a computer scientist? For Don Knuth, being a computer scientist solves an identity crisis, and he can be part of fantastic faculty at Stanford. Two questions. Why did people in the computer science field think his work only consisted of artificial intelligence, number analysis, and programming language? As Dr. Knuth said during the talk, it occurred to him that he did fit into any of those categories and had no way of explaining what they did. So Tate thought his work consisted of those branches that how he came up with the name analysis of algorithms. Three questions. Why his work called algorithm analysis? Dr. Knuth tells us that at that time he did know what it meant, but his work needed a name, and he remembered that Richard Belmont coined the term dynamic programmer, and everyone started using it. So he started calling it algorithm analysis until it became a well-known discipline. Also because he knew that what he linked doing was analysis of algorithms. Fourth question. How do you know an algorithm is correct? Dr. Knuth tells us that no to botfly. He proved that programs are correct using something called invariant assertions. What are invariant assertions? It's a way to know which algorithm to use, which one will be faster, which one will use for resource and less memory, and is service to demonstrate that an algorithm is indeed correct. Sixth question. Why is one algorithm faster than one another? Explain an example where you have an algorithm with two solutions. The first algorithm should use the summation of n numbers in sequence. Example, the summatory of the numbers 1 to 100. The specific algorithm can be correctly rewritten using a mathematical model left to use by Mr. Carl Friedrich Gauss, which I say in the movie Measuring the World. We led movie on to the first algorithm with use a loop and adds number one by one until it reaches n numbers. This in a slow and inefficient process required the machine to performance and operation up to n times. The algorithm uses mathematical formulary only requires a single operation, making the algorithm cost much lower. This shows us that one algorithm is faster than another when it has to performance fewer operations. Once again, underscoring the great importance of algorithm analysis within the programming. Seventh question. What example of an algorithm did Dr. Knuth use to explain his analysis? Why do you think he used that specific algorithm? During the talk, Dr. Knut showed use an algorithm used to find the maximum of any given numbers. He using this algorithm because it shows how a simple algorithm is also inefficient, and that using a mathematical model, the algorithm can be model correct, and also because it shows exactly what he means by the term algorithm analysis. Eighth question: what was the starting point that led Dr. Knut to see what kind of mathematics was used for this analysis? Dr. Knut tell us that the mathematics he was knew was not useful for algorithm analysis, so he began looking at other areas where there was other literature and learning more about the Starling model, which he had seen in puzzles. He called this model concrete mathematics. Ninth question: what do you consider to be the most important contribution Dr. Knut made to algorithm analysis? The fact that is show use that we should use accept that an algorithm's work but that it can be optimized to achieving great efficiency and reducing computationally resource expenditure. 10th question: what do you consider to be the most significant contribution of algorithm analysis to your training as a system engineer at UFPS? The ability to tackle optimization problems which will service me in the future a future engineer and contribute to technically advanced that will benefit future generation. Thank for your attention.